Up until this point, we've been mostly dealing with linear functions and then with some quadratic functions. So we've been dealing with functions that had x to the first power or x to the second power. But as you can see from this example here, we can have variables or x values or any variables to the third power, fourth power, fifth power, etc. So before we can get into our adding and subtracting polynomials, let's talk a little bit more about what a polynomial is. This example here, 2x to the third plus 5x squared minus 4x plus 7. This is written in standard form, and I'll talk about that in a second. This 2 right here, 2 is called the leading coefficient. We've talked about what coefficients are in the past. Make sure I spell it right here. Okay. Our coefficients are the numbers, when I say the numbers attached to the variable. So our coefficients are 2, 5, -4, and 7. Our leading coefficient is going to be not just the one that comes up front, but the one attached to the variable with the biggest exponent. This exponent here, that's called a degree. Okay, so this 3 right here, that is the degree of that term. This 2 right here, that's a degree. This 1, even though we don't write it, that's a degree. And what's funny is this also has a degree because we could write that as x to the 0. So this is what we call a third degree term. This is a second degree term. This is a first degree term. And this is a 0 degree term. If there was more than one variable, let's say it was xy, and this was x to the second, y to the third, we would call that a fifth degree. We just add them together. Okay, so this is a third degree, second degree, first degree, and 0 degree. If we want to find the degree of the polynomial, it's just your greatest degree term. What do I mean? The degree of this polynomial would be 3. It's a third degree polynomial because that's the biggest term, or it's the biggest degree of each term. Okay, so don't get caught up too much in the language, but you need to understand it because it's just going to be referred to and it's going to be expected that you know it. Okay, now standard form, this right here is written in standard form. And I will try to spell this correctly. Standard form is when you write it in decreasing degree by decreasing degrees, and each degree is accounted for. And what this means by which each degree is accounted for, I'll explain what that means in a second. Okay, and actually I'm going to put a little star by this one. We don't necessarily write each degree, but you're going to need to for other parts. So we'll come back to that. But basically standard form is decreasing degrees. Okay, so let's look at an example. This example says identify the coefficient of 4 minus x plus 2x to the third. So let's write this in standard form and account for each degree. Very first thing I'm always going to do is go keep, change, and make it all into addition. Now, standard form, we're going to write decreasing degrees. This is a 0 degree because it doesn't have a variable. This is a first degree, and this is a third degree. Notice we're missing a second degree. So we're going to write this in order. 2x to the third plus, what about our second degree? I'm going to write that as 0x to the second plus my first degree, my negative x, and my 0 degree, which is 4. So standard form, our degrees are decreasing, and I did account for this second degree. Even though it's not there, we multiply it by 0, it won't be there. That's going to help us to identify the coefficients. We don't need to write that if it just says in standard form, but we do need to write it if it says identify the coefficients. So the coefficients should be pretty easy to pick out here. What numbers attach to each of these variables? 2, 0, yes, you do need to include 0. What's here? -1 and 4. So our coefficients, because again we could write this as x to the 0 if that makes more sense why we have to include the 4. Okay, our coefficients are just the numbers attached to our variables. Let's look at another example. Well, before we look at an example, we have to name our polynomials, and we name them up to 3 terms. One term is a monomial, mono means 1. 2 terms is a binomial, bi means 2. And 3 terms is a trinomial. Think triangle, 3 angles or 3 sides. So we can specifically talk about polynomials when they're monomials, binomials, or trinomials. 1, 2, or 3 terms. We don't really go past that. If it has 4 terms, we just call it a polynomial. Look at this example. It says to give the degree and classify the polynomial by degree and number of terms. And I'm going to draw a couple lines in here just so it's a little bit easier to keep these separate. And I know there's lots of examples here, but I wanted to show you all different types you're going to see. Okay. So we're going to classify it by its degree. That's what we just did. We're going to be what we classify it as. Okay, so and I'll go through the different choices we have for that, and then classified by the number of terms. Then we're going to get into our monomial, binomial, trinomial, just polynomial. So let's look at this first one here. 5. What degree is that? Remember, it has an x to the 0, so we're going to say it's a 0 degree term. We're going to say that this here is just a constant term. It's just -5. There's nothing else it can be. So when we say classified by degree, we say it's constant. It's a constant number. And classified by the number of terms. Well, how many terms are here? Just 1. And remember, if it's just 1, it's called a monomial. Okay, let's look at example 2. What degree is this? Well, remember, we can put a little 1 by the x, so that's a first degree polynomial. We classify it by its degree. Anytime there is a variable written to the first power, whether we write it or we don't, that's linear. Why is it linear? If you were going to make an input-output table, or if you were going to use slope-intercept form, or however you were going to graph this, it would be a straight line. Actually be decreasing by 2 because that's our slope every time. Okay, so we say it's linear because it's x to the first power. Again, how many terms is this? Just 1. So that's going to be a monomial. Look at the next example. Okay, what degree is this one? Well, we have an x to the first, and we have an x to the 0. Okay, therefore, it's still a first degree polynomial. Classify it by its degree. Well, what is our x raised to? It's raised to the first power. Every time an x is raised to only the first power, that's its highest degree, we say it's linear. We could graph that and be a straight line. Now, how many terms do we have? Remember, terms are the parts of an expression being added together. In this case, we have 2. 2 terms is a binomial. Okay, let's look at this next one here. What degree is this? We have an x to the second, and we have an x to the 0. So our degree of a polynomial is its largest degree, so that would be 2. Classify it by its degree. Well, if you think back to the last chapter we did, anytime there was an expression raised to the second power, when we graphed it, it'd be a parabola. If your degree is to the second power, it's a quadratic function. So here's what we got so far. No variable is constant. Variable to the first power, it's linear. Variable to the second power is quadratic. Now, how many terms does this have? 1, 2. So this is also going to be a binomial. Oops, and I forgot to switch to red, so we'll do that now. Okay, let's look at this one. This is x to the third, x to the first, x to the 0. So the degree of the polynomial, its highest degree is 3. So now let's talk about how we classify that. No variable is constant. Variable to the first power is linear. Variable to the second power is quadratic. Variable to the third, we say, is a cubic function. Okay, raised to the third power, cubic. Now we have 1, 2, 3 terms. 3 terms, remember, is a trinomial. Okay, and looking at the last one here, What degree is this? We have x to the fourth, x to the third, x to the second, x to the first, x to the 0. See how handy this comes when it's written in standard form? We really don't even have to go through all of them if it's in standard form, because the greatest degree is always going to come first. So this is a fourth degree. Now, since this is a fourth degree, that is what we call a quartic. Don't stress out too much about quartic, even about cubic. You will get into some cubic functions, but you spend most of our time in like linear and quadratics. Fourth degree is a quartic, and there's 1, 2, 3, 4, and 5. Remember, anything over 3, we just say it's a polynomial. So all of this terminology, this is just something you're expected to know. If they ask you what degree polynomial is, they're asking what the greatest number of exponent is, what the greatest exponent is. Once we're comfortable with this stuff, we'll be able to go to the next step and actually add and subtract polynomials by dealing with their like terms.